Okay, we are here for the 8 o'clock Zoom meeting for Math 1113. And I think I'll start with where I left off, section 5.4. And we'll work some problems from section 5.4, page 473. 5.4, start with, say, one like 27. Problem 27, find all angles theta between and 180 degrees for tan theta equals 5. So this group, we'll work on from this group, then one from this group, and then on to 5.4. It's too fast. All angles theta between 0 and 180. And 27, the tangent theta equals 5. All right, the tangent theta is positive in the first quadrant. If you want a picture of this, it basically means you want the angle whose y leg is 5 times the x leg. Remember, this is equal to y over x, so you could have 5 over 1. Find theta where the y leg is 5 times the length of the x leg. And of course, this is what our tangents are for. So here's y, here's x, here's theta. 1 tan theta equals 5. So to find theta, take arctangent, both sides, or inverse tangent, both sides. So inverse tangent, tan theta, inverse tangent of 5. Now, this is an angle. Your answer comes out in whatever mode the calculator is in. So they asked for degree mode here. We want the calculator in degree mode. Let's see if we've got that. Yes, we do. But you could do this in radian mode and your answer would come out automatically in radians. Okay, so theta here then, arctangent 5, tangent of 5, 78.69 degrees. It did say 10th place, round your answer to 1 decimal place, so we'll call that 78.7 degrees. I'm not picky about the rounding. I wouldn't do a true or false based on little picky rounding like that. Okay, now that is in the first quadrant. Ordinarily, most of the time they ask for once around the circle, 0 degrees to 360 degrees. This just asked for 180. So I'm going to work it as if it's 0 to 360 and then see if we can get another one. So the only other quadrant where things are positive is actually in the third quadrant. Theta, your reference angle is 78.7 degrees. That reference would be 78.7 degrees, and so your other angle would be equal to 180 degrees, add 78.7 degrees. And that's going to come up 258. 58, dyslexic this morning, 258.7 degrees. If it was worded 0 to 360, you would include this. But since it's worded 0 to 180, the only answer or angle between 0 and 180 is your 78.7 degrees. At 78.7 degrees, your y leg is 5 times your x leg. Again, between 0 and 180, between 0 degrees and 180 degrees. A lot of times they're worded between 0 and 360, and you would include this if it was. But it isn't, so don't worry about it. All right, what about gibberish like the group from between 29? We'll try problem 31, page 473. Find the exact value of the expression secant of arcsine of 12 over 13. Find the exact value of secant of arcsine of 12 over 13. All right, you work these out by drawing a triangle. The triangle is labeled by this. This is an angle. And we'll call it an angle, arcsine of 12 over 13. The sine of theta then is sine of arcsine of 12 over 13. That's less than 1, so it's in the domain. So this is equal to 12 over 13. Sine of theta to 12 over 13. And remember, that's opposite over hypotenuse. So I just went through this just to show you, it doesn't matter that it's sine or arcsine, you still label it by the same definition, opposite over hypotenuse. So I draw a triangle. Opposite's 12, we'll put the angle here, and yes, you could call this arcsine of 12 over 13, and the hypotenuse is 13. I'll just call this leg x. So x squared plus 12 squared has to total, you may already know the answer, it works out even, it's going to work out 5. X squared plus 144, 169. Minus 144, x squared is 25, so x equals 5. Square root, x is 5. Now, a cosine of this, of arcsine of 12 over 13, that is equal to adjacent over hypotenuse. That would be 5 over 13. Writing it down, you don't have to write it down, but I'm trying to think. Okay, cosine is this, secant is the reverse. Secant then, meaning reciprocal or flip, of arcsine of 12 over 13, that would be 13 over 5. That is its exact value. There's an example of one of those. And so what 35 and 37 do is generalized to a general x. Generalized to a general x. 35 or 37, rewrite the expression as an algebraic expression in X. And it just generalizes what we just did in the previous section 31 with numbers. So we'll try 35 first, and then maybe I'll show you 37. A cosine of an arcsine of X, find a formula. You can put this over 1, and what I just tried to show you is that sine arcsine doesn't matter. It's still opposite over hypotenuse. So when you draw your triangle, you stick your X on the opposite leg, 1 on the hypotenuse. So we can call this leg, I'll call it U, just use a different letter. U squared plus X squared equals 1 squared. U squared then is 1 minus X squared. 1 squared is still 1. Subtract the X squared over. U is then the square root of 1 minus X squared. Well, that's the formula for this leg. Makes sense, and basically in plain English, you want to, if you're given hypotenuse and the other leg, you want to square your hypotenuse, square your leg, subtract, and take a square root to get the other leg. If you're given both legs, you square both legs, add them up, and take a square root and get the hypotenuse. Cosine of then the arcsine. So this leg, you can literally label this angle arcsine X. A cosine on that arcsine of X is adjacent over hypotenuse. So it's the square root of 1 minus X squared over 1. Adjacent is the adjacent side, that's the hypotenuse. So a cosine of arcsine of X is the square root of 1 minus X squared. There's an algebra formula for it. They did this in history for hundreds of years because you didn't have calculators. You couldn't punch these keys directly. So you work it out with a formula like this. Just to give you some confidence, I will punch, use an X, use X equal, you can't use any random X. Remember, you've got to be in the domain of arcsine. A half should be legal. Domain of arcsine is range of sine, the range of sine minus 1 to 1. Yeah, you got to be between minus 1 and 1, the domain of arcsine. So I'll punch a cosine of arcsine of a half. And over here I'll punch square root 1 minus 1/2 squared. See, so now you have calculators where you punch these labels directly. Probably want to be in radian mode. Yeah, we want to be in radian mode. So radian mode, although it might not matter. It should work either way, actually. Cosine of second sine, I use 0.5, 0.866. Square root 1 minus 0.5 squared. The same thing. So I hope that proved something to somebody, or unfortunately it may have proved only something to me. We'll try 37 before we go on to 84. Find a formula or tangent of arcsine of X. Well, I can use the same triangle as in the previous problem. That's over 1. So opposite over hypotenuse. I don't have to redo all the, hopefully from the previous problem, you get the same formula for that leg. And the tangent on this will be, of course, opposite over adjacent, ratio of the legs. Again, this is arc sine x. So that will be x over the square root of 1 minus x squared. It's an algebra formula for that problem. Once you see it done, it's not that hard. All right, let's go on to section 8.5.5. Section 5.5, the law of sines. They give it to you here. If you saw this, if you took high school trig or not. It's a pretty simple idea. It says the sine of any angle over its opposite side. They match these things. So they use big letters. If you see this picture here, kind of frozen. Okay. Back. Okay. They use capital letters for the angles and label the points of the triangle by capital letters for angles. Then they stick small letters for the lengths of the sides opposite its matching angle. So side little a is opposite angle A. Side little b is opposite angle big B. And side little c is opposite big angle C. Okay. So I'm frozen on our, see if we give it just a few seconds to come back. And okay, maybe it'll come back. Okay. It works off the area formula from, I think it was 5.2 maybe, or maybe 5.3. Yeah, right here. We showed you this. Okay, here's how it works. I'll draw their same picture. I think they put the A here, the B here, the C here, angle C. So little c, little a, little b, like this. So you can write 3 area formulas. All right. Area, you can write it 1/2 the B and C, any two sides, let's say B and C, sine of angle A. Angle A is between B and C. So the point being, that angle is between. You can also write it, if I work on angle B, 1/2 AC sine of angle B between A and C, and 1/2 AB sine of angle C. Now you can see, working all, I got used to working with 3-sided equations, but just to shorten it up, everything's got a factor of 1/2. You can get rid of, multiply everything by 2 or divide by 1/2 all the way through, giving you BC sine A, AC sine B equals AB sine C. Divide through by ABC. It's as easy as ABC. C. ABC. ABC. Cancel your letters. BC there. AC, A, and C. AB here, AB here. And voila, a sine of an angle over its opposite side is equal to the sine of any other angle over its opposite side equal to the sine of its angle over its opposite side. Law, I'll call it LOS, law of sines. It's just a scheme, the sine of any angle over its opposite side, equals the sine of any other angle over its opposite side. I also use it upside down. You can use it upside down. So A over sine big A is then equal to B over sine big B equals C over sine big C. You use it two at a time. Two at a time. Okay, I usually, whatever scheme I use, I usually put the unknown here. I usually always start with my unknown. Or here. And then set it up so I can solve. Give you a few examples. Why don't we start with, I think I've worked number 3. Page choice is 5.5, page 479. Put C there, big A, big B, 26.7, 52 degrees, and 70 degrees. Call this side X. You can call the sides anything you want. I'm calling it X instead of little a. I guess I'll use little b opposite big B. Okay, and it just says find indicated side X or angle, so we'll find X. And so I basically set up a proportion. Use LOS, law of sines. You set a proportion. So I start with the unknown. I start with it. You can do it any way you want. There's lots of ways to do it. I start with the unknown. So I start with X, and I put it over the sine of the opposite angle, 52 degrees. Now I have to look then at what else I'm giving. Since I started with, I'm using the scheme where my sides are on top and my angles are on bottom. And of course, you can reverse it if your angle is unknown. So I need another known side. So I need, the only other known side is this 26.7, but its opposite angle C. So find angle C. Of course, all angles add to 180 degrees. So angle C plus 52 degrees plus 70 degrees, that's total 180 degrees. All angles of the triangle total 180 degrees, doesn't matter if it's right or not. So C is 180 minus 52 minus 70. Now I'm being really anal here to write the degree symbol, but when you're doing just arithmetic like this, it doesn't matter if you're in radian mode or degree mode. You're just combining numbers. 180 minus 52 minus 70. See that? I'm at 58 degrees. So that's sine over sine 58 degrees. So this is 58 degrees. So then I multiply by sine 52 degrees on both sides. You could also cross multiply. This times this times this. I just do whatever I have to do on the x. So I get one expression of 26.7 times sine 2 degrees and divided by sine of 58 degrees. Now you need to be in degree mode. Degree mode. When you're doing a otherwise you won't get the correct value out for the function of sine or cosine or tan. When you take a sine, cosine, tangent, that's when it's important to be in radian mode or degree mode. Simply combining this, it doesn't matter. Okay, so I'm gonna punch it all at once. 26.7 sine of 52 over sine of 58. Just double check. I am not in degree mode. Got I checked. Enter. In fact, I did that calculation in radian mode. It doesn't matter. Okay. So I need 26.7 sine 52 divided by sine 58. Okay, so I punched it correctly. Enter 24.8. Here's another point about their little convention with how you report your answers and rounding. You report answers to the precision in the problem. So notice the angles were given as whole numbers. So, and again, you're going to get whole number out, so there really wasn't any problem with that. But notice that the side given was given to one place. So this would be reported to one place, same as in the problem. And again, I'm not super picky, and I won't pick a true or false answer. You get 25.5, I get 25.6. I'm not going to be that picky on the true or false answers. I'm going to try to make it more obvious than that. Okay, I'll try another example. Go down to may have done problem 9. Let's see. Problem 11. 480, we're still in 5.5, problem 11. Put a 12 there, call this angle A. 12 here, call that 68 degrees. Put a C there, and a big B there. Call this little angle side A. This would be angle A and angle B. So what they want, solve the triangle. So this means find, in this case, all missing angles and sides. So basically you want to find little a, angle B. If we can get one of the angles, you can always subtract the other two from 180 and get the third angle. You can't play Pythagorean theorem. You can't assume it's the right triangle. So just to get arbitrary how you go about it. Let's see, you're given this, you got to look at what you're given. You're given this angle and its opposite side, so that's one side of the proportion. And we're given the 12 here opposite the B. So we got to find B first. Find angle B first. So again, I start with the unknown, sine of big B, and over its opposite side is 12. Is equal to the sine of 68 degrees. If you start with an angle, you got to keep all your angles on top. If you start with a sine on top, you got to keep all the sides on top. And it's over its opposite angle is 12. Now I'm going to multiply both sides by 12. Actually, it's going to cancel the 12s on both sides. And actually, you're going to find, don't really need to do the arc sine, but sine B is sine 68, and B's got to be 68, but we'll do the arc sine on both sides. Sine B, sine 68 degrees, so B is the arc sine of sine of 68 degrees, which is 68 degrees. Makes sense. Length of side opposite, that means your angle is spreading out exactly. If this is 68 and that's 12, then this has to have the same spread if that's identically 12. All right, so we know angle B is 68 degrees. Now we could get angle A. So for step one, step two, angle A would be 180 minus 68 minus 68. $44. And now you can play the third side, little a, however you want. We got this at 44, we got this at 68. There's lots of, you can't do Pythagorean theorem here. Can't use that, it's not a right triangle. So 3, I'll play it A, since we want it directly, over sine 44 degrees. And then you can either, you can use this 68 over 12, sine 68 over 12, or I think it'd be 12 over sine 68 on either one. Sine 68 degrees over 12, multiplied by sine 44. And your A then is, tough morning. I knew it was bad. You never wind up with the signs on the same level. Tough morning. So it's A over sine 44 degrees is equal to 12 over sine 68 degrees. Yeah, when those signs worked out this on the same level, but wait a minute, what am I doing here? So sine 44 degrees, sine 44 degrees. So your A is 12 sine 44 over sine 68 degrees, making your A 12 sine 44 sine 68. 8.99. Again, if you left it 8.99, I wouldn't mark it wrong. The precision in the problem, it's whole number precision on the sides. Whole number precision. So we're going to call it A equal 9. Either one is fine. It's not like I marked this wrong and this right. Not that picky. All right, let's set up one more where you've got to read the triangle and set it up. So try to play problem 15. Problem 15, your angle is 30 degrees. Angle C, 65 degrees, and little b is 10. All right, these need to be set up specifically. I'm going to use their, you can't really just throw the numbers randomly around the triangle. So I'm going to use their convention, the A, B, and C there. Call this 30 degrees for angle A, call this 65 for angle C, and the little b 10, see, I'm going to put opposite big B. You just can't randomly throw the numbers in on the triangle and start writing down an equation and hope to get the right answer. It needs to be set up by their conventions. So automatically, if I know two angles, I automatically, first thing I go for the third. So angle B is 180 minus 30 minus 65. Minus 30 minus 65. 85 degrees. Yep, 85 degrees. So that is 85 degrees. We need to find little a and little c. The order we do it doesn't much matter. I guess I'll go for a first. A over, again, its sine of its opposite side is then equal to, see, I can't use little c. I have to use the 10 over sine of 85. We seem to have frozen again. There we are. Multiply both sides by sine 30 degrees. See how the sines always work out on different levels? So 10 sine 30 over sine 85. 10 sine 30 divided by sine 85. 5.019. Seems to be whole number precision, so we will call that A equal 5. And then number 2, C. Well, I got two number ones. All right, if you want to call that number 1, that's number 2, that's so number 3. C over sine, find C over, and its opposite side is sine 65. And I can use either the A or the 10. I guess I'll stick to the 10 over sine 85. So multiply by sine 65. C would then equal 10 sine 65 over sine 85. Sine 65 divided by sine 85. 9.097. But again, to their precision, you can just call it 9. All right, that pretty much covers section 5.4 and 5.5. We will get 5.6 next week and have the test next week. And it will be a proctored test next week, so we will be giving out instructions for that. And we will have one section to cover next. There won't be a quiz next week over specifically 5.6. We'll just do out 5.6. Problems out, probably a WebAssign problem out. No quiz, but there will be a test overall of chapter 5 next week. Test 2 over chapter 5 next week. And it will be proctored. We'll get our proctored test in early. Instructions will be given out next week. All right. Otherwise, we will end the meeting and keep the same Zoom schedule, full Zoom schedule next week. See you next week.